So factoring by groups is, another way that we could factor things. So this is usually in the case where maybe not all our terms have a common factor, but groups of them do. So if an expression has 4 or more terms, there may be common binomial factors, meaning I could take 2 terms and factor something out. Often, in order to identify a common binomial factor, we must regroup into 2 groups of 2 different terms each. This is going to look a little weird at first. So what we're going to get at as a binomial factor is that I have x plus 4 times n, and I got plus x plus 4 times y minus b. So I have, well, let me do this. I have a term here and a term here. And both of them have an x minus 4 in them. So what I can actually factor out is I can factor out that x minus 4. Or x plus 4. I don't know why I keep thinking it's minus. So if I, like I said, when we factor out, we're essentially kind of dividing it out of the term. If I do that, all I'm left with here is m. And then if I divide this by the x plus 4, these terms cancel each other. And I'm just left with the y minus b. So in this case, all I did is I factored out that x plus 4. So I was factoring out a binomial factor for each. So we're going to actually do a little bit more with this here in just a second. So admittedly, this is one that it takes a little bit to just get the concept in your head. Usually once we do it a couple times, everyone usually has no problem. Like I said, it just looks weird at first. So we factor by grouping. What I'm going to do is just pair a couple terms together. So just so you know, we are using cases where factoring by grouping is going to work. Doesn't always work. Sometimes you have things that just can't factor. But in this case, we should be able to factor. So we have y to the 5th plus 5y cubed plus 3y squared plus 15. So it really doesn't matter which ones I pair together. I just pick 2 and just see if I can make anything work. So I decided I'm just going to put the first 2 together as a group, y to the 5th plus 5y cubed. And so I want to figure out what can I factor out of these 2 terms. And I can't factor a y out of an x out of both. I can't factor out a y cubed. So I factor out y cubed. I'm just going to be left with y to the squared here, and then just left with 5 over here. So I grouped these 2 terms and then factored. We're going to put a plus in between because now we're going to do this other group. Here I have 3y squared plus 15. So something common I can factor out of both of these is actually 3. Now if I factor out 3, I'm going to be left with y squared plus 5. So this is very similar to what we just saw in the last problem. So we have 2 terms. They both contain a factor of y squared plus 5. So what I can do is I can factor this out of each one. So I have y squared plus 5. And this factored out, all I'm going to be left with, like I said, I'm pulling this out as a factor. What gets left behind then are these 2 terms. Then I just have y cubed plus 3. And that is what we call factor by grouping. So I have actually made 2 different factors here. And if I went through and I FOILed this or did a distribution, I should get this whole thing back. That is what factoring by group is. Like I said, it takes a little bit to get used to the fact that what you're factoring out is not a number or a variable, but you're factoring out a whole binomial. So just for practice, see if you can attempt this on your own, A, B, and C. So you're going to do factoring by groups. You're going to pair your first two terms and then your last two terms. Factor out something common, and then you should have a common binomial that you can factor out of both of your remaining terms. Okay, so for A, I put the first two together. I have 3x minus 3y. So the one thing that both these have in common is 3. So I'm going to factor out 3. And once I do that, what's left behind is just the x minus y. Now we're going to write plus for now, but we're going to look at this next term over here. So I have ax, ay, and what they share in common is a. However, if you remember, I said we had something like this and we were getting with a negative, what we like to do is actually pull out a negative. So we're not going to pull out just a, we're going to pull out negative a. And when I do that, what's left behind is that this is going to now become x, and this is going to change since I'm factoring out a negative a, negative y. So if you got stuck on this one, you couldn't figure out why you weren't getting the same binomial, you need to factor out a negative. So once I do that, that's going to give me the same binomial of x minus y and x minus y. So I'm going to factor out my x minus y. And what should be left over are these two terms. So I'm going to be left with 3 minus a. Well, you could have said 3 plus negative a. And also, just so you know, because occasionally this happens, if you ended up getting this instead, that is also correct. Or you may have ended up with, like I'm trying to think what it was. I believe it is this you may end up with. That's also a possibility. Okay, so for B, this will be the same thing. We're going to match these two together, and then we're going to match these two together. So for 6x squared plus 2xy, both are divisible by 2 and an x. So I factor out a 2x, I'm just left with 3x plus y. I'm going to write plus here again. So between these two numbers, remember we're starting with a negative, so we're going to pull out a negative something. But we got 24 and 8, and both of those are going to be divisible, well, not only just by 2. So you might want to be careful and not just go, hey, they're both divisible by 2, or they're both divisible by 4. Keep going, go, well, actually, they're both divisible by 8. So if I divide by negative 8, that's going to change this from negative to positive. So this is going to become positive 3x, and this is going to become positive y. So we see we both have a 3x plus y. And what's left over is my 2x here and my negative 8 here. So there's a possibility, and you may have noticed that I actually can factor this a little further. So completely being factor, if you want to factor something completely means we can't factor my terms any further. And actually this one can factor just a little bit further. Both of these are divisible by a 2. This is actually 3x plus y times, I could pull out a 2x minus 4. And we'd probably write that 2 out front. So we would just say 3x plus y times x minus 4. So sometimes we could just factor a little further. Or you may have at the very beginning realized that all these were divisible by 2 and pulled the 2 out first. But just something to always be careful of is look at your factors and see, can I actually factor further? Like here, these don't factor any further. Here, that one's okay, but this one can be factored further. So C is my last one here. So I'm going to pair these two terms and these two terms. So for x cubed plus 2x squared, I can factor out x squared. We're just going to leave behind x and 2. And then here I have 2x minus 4. And I can factor out a 2, which is going to leave me with x minus 2. So this one, like I said, you can't always factor. Sometimes you'll have 4 terms, but you can't actually do a factoring by group. But when I get here and these are not the same, we can't factor by group. So I think factor by groups, maybe other ways that this factors, it's just not anything that we're looking at. We're just looking at factor by groupings. And we definitely can't factor this by grouping.